Hello, everybody, and welcome to today's webinar presentation, Improving Delivery Engineering with Continuous Testing, brought to you by Emtec. I'd like to introduce you to our presenters, Piyush Shah and Larry Gordon. Piyush is a digital services practice lead and a solution architect with Emtec. Emtec is a well-established IT services provider focused on product engineering. Piyush has 10 years of hands-on experience in building teams and best processes for digital product engineering projects. He is working with the latest tools and technology for leaders in the logistics, supply chain, and digital real estate industries. He helps Emtec clients incorporate continuous testing into their software engineering processes. And Larry Gordon heads the go-to market for Emtec in North America. With that, I'll hand it over to Piyush and Larry.
Thank you, Lucy. It's a pleasure to be here with DZone and the DZone community, which I've been part of for many, many years already. And today we're talking about continuous testing and delivery engineering, which is how we build new digital products for our clients. And Piyush is a terrific presenter for this today. He is working very, very closely with 6 really prestigious clients, enterprises here in the United States. They range from mid-sized but well-known to large enterprises, and he's transforming the way they do testing, of course, using modern continuous and automated testing practices. So we're really lucky to have Piyush here today. We're really lucky to have the DZone community here today. Emtec does this every day for our clients, and we'd love to help anyone out there do it as well. And now I'm going to turn it over to Piyush. And good to see you this afternoon on the East Coast, Piyush. I know you're in Chicago, so I think it just turned afternoon.
Yes. Thank you so much, Larry. Thank you so much, DZone, for giving this opportunity. For sharing thoughts. I've been a DZone trader as well, right? So coming to, before we jump into continuous testing, let's take a look at where in the overall picture of delivery model does continuous testing play a role, right? So I'm going to kind of start with what a continuous delivery is, what kind of challenges we see there, and then focus specifically on one of the blocks of that delivery engineering framework, which is continuous testing, right? And towards the end, I have a small demo to walk over on how that whole story translates into something working from a continuous delivery perspective. Right? So if we look at software, right, it has really become an engine for business innovation. If we look at Gartner's 2022 software engineering leader survey, highly ranked leaders have talked about delivering innovative software solutions and delighting customers beyond their expectations as one of the top 2 rewarding aspects of their jobs, right? So to meet this kind of need of a modern software, there are several questions to really look back and answer, in terms of, am I spending too much on my software engineering practices? Is comprehensive testing affecting my go-to-market? Are my practices currently resulting in that quality improvement that we would look for? And my stakeholders, my customers, are they getting immediate value, immediate feedback, about the whole process, right? So a good delivery engineering framework will help modernize the way you deliver the software, right? Investing in continuous delivery is going to significantly reduce a technical debt for an organization. It's going to be a competitive edge for them, right?
Piyush,
so
we're having a little trouble seeing the slide progression. Are you clicking from slide to slide? I know we had it prior.
Not yet. Okay. So I'm on my second slide now. Right?
Thank you.
So yeah. So looking at continuous delivery, right? So continuous delivery is about it starts from that model of continuous development. With agile practices coming into play, you're not going to have a typical traditional waterfall model, but more in that line of building a code to taking it to production in a more continuous fashion, right? So it's a modern development approach where code changes are released to production, pretty much automatically, right? So it requires automated build, requires automated test, configuration, deployment from source code to a test or a production environment, right? when properly implemented, developers will always have a deployable ready artifact that has passed through all the standard testing process, right? So if you look at key benefits on how continuous delivery can help you, is it's going to make our software lifecycle efficient and super rapid, right? Because you always have something that you can put on production. It makes developers extremely productive by freeing from a lot of manual tasks and mundane work that they have to do after finishing the core implementation of building software, right? So you can really now discover bugs and address much earlier in the cycle before they really go into becoming a massive problem, right? So you can change your approaches. You can be nimble and agile in terms of your implementation if you know what issues are going to come up with what you just did right now, right? And then the frame of mind remains in that state while you're solving that problem and not moved on to another phase of project. So if you look at that in a nutshell, continuous delivery is going to help you deliver your software updates to customers much faster and more frequently, right? But this needs a lot of key foundations, right? So we're going to see what really to make this a reality, what really framework you need to put in place so that you're in a position to reap these benefits of continuous delivery, right? So here's a quick graphics depict from Gartner that shows how customer value reaches.
The slides aren't progressing. Sorry.
You're still seeing my old slide, like
I see the title slide, but I don't see the progression through the kind of nifty things you're doing. I hear you fine. But Lucy, the moderator, is working on it. It could be technical. It could have just happened because it worked literally 5 minutes ago. Lucy?
Yeah, sorry, I'm checking it at the moment. It seems that everything is connected. Let's see if I can try one more thing.
Oh,
there we go. It's moving now.
We have the current slide at least.
Okay, yeah. So are you able to see this?
We can see that. Yep.
Okay, yeah. So yeah, I was earlier on this slide when we talked about why we need continuous delivery really in terms of the kind of leadership survey that we talked about. This is what a continuous delivery is, right? In terms of continuous development, integration, testing, deployment, feedback, right? Continuous monitoring plays a critical role, and a continuous feedback to make this loop a real effective. So we're going to see the as we progress through it, what challenges typically enterprises run into in making this a reality, and what is a good framework to make that happen, right? So this is a Gartner graphics that I was referring to, that depicts activities in a customer in a continuous delivery for a customer value, right? So starting from a need to ideation to production journey, how we see it, you definitely need a collaborative culture, a product-centric mindset, and a whole lot of automation to make this successful in a continuous delivery adoption. But many times we see that enterprise quality is broken, right? And frankly, they sometimes don't realize that that's the case, right? We've seen shared service organization for a QA in order to gain efficiencies and for cost, right? There is a siloed structure and conflicting set of rewards between a dev versus QA, right? So defensive posturing often complicates the delivery of software and erodes a good relationship between the two groups, right? And some organizations tried, in their own fashion, a shift left by just moving people around, and that has created new bottlenecks, right? So a team, if has a single person to still take the ownership of quality, I think we are just shifting the problem, not solving it completely, right? So leadership alignment in terms of setting up a team that can be autonomous and accountable is critical in making this continuous delivery implementation a real success, right? Team and team members need to be empowered to make decisions around product design, development, and delivery. So, and the whole progress cannot happen overnight. So you really need effective change management in organization when they're transforming and going into a continuous delivery implementation, right? So what we are suggesting is a good framework, and we have seen success with that in many different organizations to make it happen, right? You want to really have your developers focus on building the requirement of a customer, and what can you do to make that really easy, right? That's what this framework is all about. So starting with this first philosophy that you're going to have one or many development teams, you're going to have delivery engineering team or teams that were going to enable this continuous delivery make a reality. So developer experience is the first and foremost thing to be to consider in building a delivery engineering platform, right? So what we need to be able to have developers focus on just building a secured and efficient, consistent code to production, right? So while there is a paradox of giving developers a full flexibility, we also know that every person on the team cannot just go his or her way to put code into production, right? So we need a secured architecture, consistent and reliable solution to do that in a more repeatable fashion once the architecture practices are established, right? So a good developer experience would be, an onboarding a developer onto a platform and in a consistent way is able to take code to production even on day one, right? When you get a requirements, if there is an ability to translate that in a completely automated fashion by creating services, from a click of a button, for example. And I have a demo that can really show this as a reality. That would really transform on what developer can, on how effectively developers can focus on doing their work and not worrying about other parameters, right? Plus, there are other things that we know in terms of security and the dependencies that we bring in from both open source and paid world need to be highly secured before putting them in production, right? Another typical challenge that we see in the organizations is around cataloging, right? So ownership of a particular service or a component or an application has to be maintained with a certain way of how teams are changing, right? The org structure changes, but it is a lot of painful way of maintaining which service component belongs to which author and how the devs have shifted in their career or within organization. So to address that problem, a good visible solution needs to be in place when handling developer experience and service cataloging, right? So the next aspect of this framework would be around the test process itself, right? So and we're going to go quite a detail into this in coming slides, right? But if you look at a few years back, World Quality Report, it clearly states out that 35% of organizations had challenges in integrating testing tools to DevOps, right? So we really need, when it comes to continuous testing, it is imperative that the testing framework is really a seamless part of the whole DevOps life cycle of taking code from repository to an environment, right? So a good automation framework will enable this seamless integration and make test authoring extremely effective, right? We have a few more variations to discuss on those on what test authoring component will really mean. A second aspect of this is, and when I say test authoring, we are really looking at three amigos, right? From a developer, QA, or a business persona in the team to come together and contribute to developing effective tests. Second aspect of this framework is a lot of times missed out in terms of how reporting solution is looked upon, right? So we really need to acquire, aggregate, and analyze the results in order to understand where the things are in terms of failures, and really go back and improve on either of our tests as well as our product, right? Data management, test data management is critical in terms of finding defects early in the cycle, right? So whatever defects you find in production, a lot of ways they may not be easily reproducible in lower level environments, right? And a key to do that is subsetting our production data into a more making it available in lower environments, right? You can't just take the data as is. It is going to involve data masking, critical information, and sizing the data in a way that you don't have to have that huge environment set up down in the lower level environments, but you still want a variety of that data available, right? So automated subsetting process is a huge value because it's going to increase the confidence in the automated sign off to production, right? If you are able to bring that data as frequently as every week, or it's going to be a huge benefit for testability of your applications there, right? Another aspect which we're probably going to go in little more details when looking at the test framework piece is, making this data available as a service, so that when it comes to effective test authoring, the test authors are focused on writing a scenario, which they can really do well if they know that the desired state of application, desired state of data already exists for them to lean on. And if we make this test data available as a service, then that really empowers the test authors to focus on effective testing, right? The next big block is definitely around the CICD ecosystem of the world, right? Like, so in many organizations, engineers struggle sometimes to just take, there are a lot of manual procedures in terms of taking code to production, right? Could be infrastructure components, or sometimes even managing pipelines for a product, right? So it's very common to have some of this sitting in somebody's brain, but not available for everybody. As organizations grow, this becomes really a terrible bottleneck in the system, right? So we need to really have a good CI/CD pipeline in place, right? The key principles to remember there would be, securing our artifacts and toolchains, which is security. So DevSecOps is a key to all this, right? It no longer remains DevOps today. We need a CI/CD pipeline as the only way to making it to production. So definitely no manual access, right? Maintaining parity with production for all non-lower environments. Build once and promote through the site pipeline. That will make sure that your artifacts are tested once and they literally move through the chain of environments. And then run your fastest tests early so that you're in a position to fail fast. The moment a developer moves out of the mindset of committing to a task and moving on and picking on something, and if he or she does not realize that there is a issue in what the work was delivered, I think it is going to take a cost of fixing that bug is still going to be higher, right? So again, infrastructure automation is not new, but the mechanism to automate infrastructure has evolved substantially in cloud era, right? So due to the complexity of environments and tool chains, containerizing alone is not sufficient, right? It's imperative to automate the life cycle of containerized software. And so, Kubernetes is widely used from orchestration perspective. But a next stage really we want to go and see is you want to make the shift left strategy more effective. And so environment recreation or micro environment strategy, how I call it, is as a developer, if you are on a feature branch, you would still want to run your end-to-end test on a branch that really needs abstraction of all your dependencies at that point, be it data source, be it event ecosystem, be it other services that you have. And a highly sophisticated virtualization solution is a key to making sure that your external dependencies are addressed when you are in a position to provision a microenvironment, run the full test, and get that confidence of creating a shippable product for production. So continuous monitoring, again, monitoring relies on telemetry, like which takes many forms, like managing the collection, ingestion, and analysis of the telemetry is on a time critical basis is fundamentally, really needed for a good operations. So if you look at Gartner prediction, it says by 2025, 70% of new cloud native applications will be on an open telemetry platform instead of a vendor specific, right? And that is going to be a huge seamless integration for each technology to move into setting up the AI ops and monitoring and the ingestion process, right? So data-driven analytics and ML is enhancing the effectiveness in the monitoring, and it's really what AI ops are really using behind the scene to make that effective, right? And our service catalog that we talked about in the developer experience is another key way of looking at the ownership and hooking it up to AI ops, making the cycle really complete, right? You need to know who's the developer I'm talking to, and if somebody needs to look at it, who's really the ownership of it, right? So that feedback mechanism of build, measure, learn is critical from a loop perspective to make continuous delivery complete, right? We need to have dashboards and visibility literally on a real-time basis, because if you know if there's something that is slow and broken, and if you're not realizing it, you know the developers have moved on to next phase of work and they still don't have a good value. It's like a long running build is a good example of it, right? If it takes 2 hours to come back with a full set of test results saying the build pass, I think by that time can't be commit or trigger driven, because you want to make 15 commits and you can't really have those 15 builds in a day, frankly. So a quick feedback is really required. You can use active messaging instead of relying on team members to proactively searching for information in this case. So when you put this framework in place, what you're going to realize is it doesn't have, these changes don't come overnight, right? You really need a good governance and change management, and you're going to have a, dev team pilot with these, provide a feedback, and then, really accelerate and scale, right? So you don't want to wait till everything is done and in place before transitioning over. That transition can't be overnight. So I'm going to kind of pick up, if you look at each of these blogs, can really, there's a way to go deeper in each of them and how they can be done. For this discussion, I'm only focusing on continuous testing, but really, if you look at it, these blogs could be talked through, in their own isolation, to go deeper in terms of how to approach them. So just stepping back from a testing evaluation perspective, right? We know that if you go back to a couple of decades, right, testing was on need basis, right? There was testing as a phase needed with black box testers. The waterfall brought in a methodology to the testing instead of being an ad hoc to saying there is going to be a phase, we're going to write down test cases. Then came, a testing center of excellence where there were some metrics put in for driving automation, eventually making it a center of excellence, and then moving on to agile testing or a distributed testing, where we said, yeah, now we're going to make testing as part of a Scrum, but really where we are looking at is integrated quality assurance as part of a DevOps process. That's where the continuous testing comes into play, right? So quality at speed while adopting new technologies is key to remaining relevant, right? So that's where testing shift is more leftwards now, where we are saying, yeah, as you build, you test them right there, right? So continuous testing is a practice of testing across every activity in the SDLC to uncover and fix unexpected behavior as soon as they're injected. This is critical from the perspective of the thought that there's a behavior change that introduces a bug or needs a fix, right? So unless you have ability to go and regress all existing behavior cycles correctly, you're not going to be in a position to find out what you broke until you know test this. So as you build, if you have a solid test built around that, that's where the emphasis is going to be on, right? So it's essentially embedding testing as a fundamental and ongoing aspect of every activity through the application lifecycle, from requirements through production, and just to ensure that business value is achieved as expected. So if you look at this notion of continuous testing, you're seeing a sea change in the responsibility. Right now, it's all shifted leftward. We're not going to have a phase in the project to say there's testing. You know, organizations have need to establish pretty comprehensive testing strategy for this, right? So there's added emphasis on security performance pretty much right from the beginning of application lifecycle, right from the design and technology architecture piece itself. So organizations are also working on building strategies for AI, right, by refining their automation approach. So you're going to use AI all the time in making judgments around how effective your continuous testing process is going to be, right? And that's where one of the critical factors for this is your ability to aggregate and acquire results of all the tests that have been done, and that maturity is going to come over time and bring in valuable insights about the product quality and where the enforcement of or quality improvements are driven, right? So it's going to drive back a point about need for improvement, and not just remediation of the fix, but really an area of improvement coming back to the dev team and seeking inputs on that, right? So when it comes to continuous testing implementation, right, it's again going to be kind of mindset change. So as we talked about earlier, right, there are silos in the organization, right? Quality is going to suffer when you put walls between developer and tester separately, right? So if you're going to make that together, your three amigos need to work collectively between creating requirements, developing code, and testing the software, right? So you have to have a team that is collectively responsible for it, right? Our center of excellence has to really diffuse and transform into a center of enablement. And that's where I look delivery engineering team as that center of enablement to make it happen, while the dev teams or the development teams focus on making that, you call them as scrum teams or agile teams, making them happen, right? We don't want handoffs and dilution of duties across the teams when we are passing. Principle of combined engineering enforces elimination of tasks being passed from one to another, right? So the end-to-end accountability remains with that group. So some of the key enablers that we need to look for in the continuous testing phase, right? So if you ask me, like, what's a definitive way of implementing a shift left methodology, right? So what it comes down to is, for every code push to a repository, we must have an accompanying testing change, right? That would ensure, and we are going to shortly see about the testing change, right? When I say testing change, we all know there are enough gates on the unit test coverage. And there are ways to look upon that pretty solid in as far as pipeline is concerned. But that unit testing change is going to cover only the bottom portion of pyramid. It won't help us test everything there. So it really, the testing change I'm talking about is unit, functional, security, performance, pretty much everything, right? So this kind of becomes a principle of our definition of done, right? So if a story is not complete until both coding and testing are completed, if we enforce that as a practice in the team, I think we're going to be highly successful in getting to the notion of continuous testing implemented, right? Another thing to keep in mind is your testability into your architecture, right? So you have to build your testability into applications, whether it's UI applications, services where integration play, or backend applications alone. If testing becomes a thought only when you build a super complex system that's highly event driven, based on streams. People, there are individual services and tons of microservices picking up data from a common source, or uh, from a streaming environment, and you really don't have a way to say, now I want to test a service that flows midway into the stream and is able to pick up, and if the interfaces are not defined, you don't have a service contract in place, you're going to have a high, real complicated challenge of solving test data generation for that service, because it really has to again start from the start for that specific service to be tested. So there are various ways of how you design your application, whether it's backend or even for front end. Your locators on your application, how are they generated, how they should be written in a way that you use all of the HTML or mobile elements effectively to help support testability. It is critical there, right? Environment parity is another factor, right? We know that we want to run lower level environments in almost similar fashion as production does, so that there are no surprises from one environment to another as you progress your code. Layered testing approach is another critical thing that makes continuous testing really successful, right? So we're going to closely look at the layered testing approach, and that's where this pyramid comes in handy, right? So you look at the bottom of the pyramid, and that's where we all are familiar about unit test being part of pipeline. But really, as you focus on as the pyramid tapers towards the end, you want to build foundational. In a lot of organizations, I have seen a focus being given on unit testing, and then it is literally a reverse pyramid of what I see here, right? So people start with the UI automation. When it comes to saying we have an automation strategy in place, all they start doing is starting to automate the end user experience of how it is going to look. And I think it's not a bad idea to automate the end user experience. I think it's not wise to always rely on that automation alone to test your end-to-end functionality. Right? There's a lot of business logic that is being built by individual services and individual components in the flow, and that really is a key to test that before you go to your end-to-end or UI application. So, as you can see, we want to have each level of pyramid ample amount of tests being written there, right? So yeah, if you look at the component and the system integration layer test, the majority of testing should occur at that layer from a functional validation perspective, right? There's another thing which talks about the test levels and the roles that are going to be involved in that, right? So we see that as you move upwards in your chain of test pyramid, or stages of your test pyramid, involvement from other personas than just developers alone is going to help us make that a critical success, right? So that really enforces or forces you to look at your requirement gathering process, to how your QAs are looking at this whole process, and your test authoring kind of pretty differently, right? You really want your requirements automated, and not everything can be done by just developer alone. Then you really need to enable a framework that allows your solution analyst, business analyst, as well as the QA persona to come and contribute to the requirements, or to the test generation or test authoring piece of that, right? And that's where you kind of divide the responsibilities within the team in terms of what's where developer needs to play a role in making things testable, or enabling testability through a test data services, but letting QAs and SAs pick up the test authoring piece of it. So before we jump on to some frameworks, I just want to bring up some of the challenges that I've seen in continuous testing adoption, right? So if you, and I bracketed them into into three different layers, right? One around technology, right? So if you look at what technologies lacks, or I don't think it's a blame of technology alone, but really how people have approached on our technology side is that automation tests have lacked coverage and confidence to sign up for production release, because that's the aim, where we want literally everything automated and signed off, build artifact to go to production, right? So test data management is a key part of it, right? If your tests are not built to use a combination of data that is more realistic for your end user experience or end user application behavior, then your tests are not going to achieve the same results as somebody testing it manually. The result analytics is a key and feedback implementation, right? So a lot of times there's a lot of focus on creating tests, but on how they are orchestrated or how the feedback mechanism is linked to the developers, it is not very well done. A lot of times you have a Jenkins build, and a build triggers a test. That test logs a bunch of results. Well, the pass or fail, but at the end of it, you don't look back, and the data is not aggregated to, the logs are wiped out after a certain number of builds. You don't have any way to derive analytics out of the failing test to see, was this really a test issue, or was this really a area of application that needs a more consistent failing fixes, right? Missing service contracts is another area, as I said earlier, where developers don't really know what's happening. You have a producer of a data and a consumer of a data, and when you develop or test one service, you're not essentially checking that the consumer was able to pick up the data, because there is an event-driven ecosystem in between. You're happily testing that this service job was to produce, and I have validated that the data was produced. And checking status 200 or a response data is not sufficient. It is imperative that we check for service contracts being made, as well as data contracts being made, right? So traceability through service dependency is a key piece of it, right? So you really need to know who's your provider of your information and who's a consumer of your information. Lack of upstream downstream visibility to have that service mesh kind of architecture is critical. Otherwise, our testing, a key challenge is, when you make a change, what do you test? Simple answer is you test everything, but that's just not practical when you have thousands of services running around. So you really want to have your upstream downstream dependencies very clearly articulated in a way that will allow you to trigger X number of tests precisely to get that confidence of signing the production, right? So process-wise, I think testability, I really think that is a big problem, is usually an afterthought, right? So you groom your requirements, you design your technology solution or a development solution, and then you think, okay, now I need to test. What do I do, right? So then that starts a problem, because when requirements were groomed, we didn't finalize or frame our acceptance criteria in a way that will translate itself into a test, right? That's the thought process of how I see it as test authoring coming into play. Test pyramid being skewed towards top, and it results in insufficient testing, right? It's long running, more fragile UI tests that are built, and that really is a big problem, right? Effort provisioning is also underestimated, because we tend to have that within a Scrum also. There's one QA responsible to test everything for 4 to 5 developers, and I think that provisioning mechanism is grossly incorrect. And we absolutely need to have quality gates in our CI/CD process, where we just don't let things move further, and there are appropriate rollbacks if the gates are failed. So there is no bigger challenge than sustenance of test automation, because you will end up spending a lot of time in creating tests, but not having them maintained, right? So quickly going to cultural change, because I'm looking at clock here, I do want to spend some time on demo here. So quality ownership is deferred to user acceptance group, right? Instead of a construction phase of your SDLC, people not ready to get out of comfort zone, right? And a defensive posture, which we really looked at leadership mindset change by having a RASI to avoid problem falling into no man's land, right? So when we come to building such framework that will address most of those challenges that we discussed earlier, I just want to step back and see how software architecture in general has evolved for us, right? So we've seen monolithic applications that had UI data together, moving on to a service-oriented phase, queuing solutions and whatnot, eventually coming down to microservices architecture with common front end, right? And then now we all know that micro front ends is also a very common way of simplifying the release cycles and strategy around front end deployments. So what we looked, a common similarity is separation of concern as a principle to test automation, right? So we are applying a similar concept to test automation frameworks, as well as to the DevOps architectures, to building a micro component architecture that will allow each pillar to be replaced with something new in future, right? So if we have to go and change, we don't have to change. So there is, just like service contracts, there are contracts and responsibility splits in this framework that allow you to go and make those changes, right? So if I put together a test automation framework model that allows us to focus on those four critical aspects separately, right? So when it comes to test authoring, a BDD based framework would allow you to have your developers QA and, as I said, 3 amigos contribute together, right? Now when it comes to BDD, it is typically looked upon as yeah, you'll have to write feature files, which we all know Gherkin as a language, but then there's always an associated behind the scene task or of implementing the step definitions, right? So we today that problem is solved in many different ways, where there are known implementations of the known keywords. So it's not really truly an English language of behavior written there, but a known set of keywords that enable you to help your automation be strictly what the keyword says, right? So that way, it's a flavor of a keyword-driven test, but really a known set of keywords from BDD that you can expand on to doing API testing. Karate is one such fine example from an open source tooling option perspective, right? That there are many others based on the technology stack that you are going to use. The second aspect and separation of concern principle really that we are talking about is test data as a service, right? So when it comes to creating tests, you really want to see that you have your data generation logic completely separated, right? So there are two key principles here: is your ability to interact with the application, and application under test interactions need to be reused when you're creating different layers of test, right? And your data generation should be abstracted as a service. So with these two parameters, your test authoring is going to be as simple as literally grooming your requirements. So you can use BDD as a way to go with a test first agile testing approach, where you really focus on an outcome. It applies to the features, which that those requirements come with a certain level of acceptance. But when those features are translated into user stories or technical stories, the technical stories can also follow the same pattern of having a given then sequence and making that reality in terms of test creation. So test orchestration, I think we discussed that we need test to be packaged the same way a developer artifact is packaged, need to have the same level of configuration and management ecosystem access as the developers. You don't want to hard code anything that is environment specific. The credential management should be followed in the same way a dev artifact would do. And then we've talked about test results. So there are solutions like report portal, which will allow you to aggregate the results and look at behavior of failures and apply AI on top of it to see what really is there, right? And at the end of it, your quality gate is really critical to making this as a sustenance model for you to really see that you're able to run those tests every time you deploy a service. So we're going to see a quick demo of most parts of this when I walk you through that from a continuous delivery perspective, right? So for this demo purpose, what I'm doing is I'm using a developer experience portal, which is open source platform that is Backstage. It started in Spotify, but today it's open sourced. Karate as a test automation framework. Again, Karate is a start. I think as a team, when you start adopting a tool like Karate, you'll have to build on pieces that things may not be available right off the shelf, but it definitely can be extended, right? Using AKS and Azure GitHub Actions as a way to orchestrate some of this and make this end-to-end flow working, right? I'll start the demo and then we can quickly see what all pieces are happening there. So if you look at this, this is a locally set up Backstage, allows you that visibility that we've talked about, service catalog and ownership visibility. It also has a lot of that mechanics of showing who is providing the API, what is the contract between them, the relationship between a producer and a consumer, kind of it. So a lot of ways it enables that dependency chaining, right? For us, it definitely has a lot of groupings and ownership capability to look at the data by teams, by by systems, or how it calls as components, and you can see what constitutes that. And this is going to be a critical integration play for AI ops as well, to know, oh, you need to go and look at it, right? From a developer perspective, as I said, an onboarding experience is, let's go and create a Spring Boot service. It's going to really start with just saying, here's the name I want, here is my packaging structure, and I'm going to give a owning theme for it, and it's going to go ahead and create a repository for me on GitHub, right? So this kind of experience ensures that there are no missed out dependencies. It puts in the initial seed code of monitoring, and you can see, okay, its folder is already created here, making sure that all the deployments are possible, right? At the same time the service was created, we created a test repository for it, which has a and this example was created already, but you can see it has some tests that are written against the service itself, right? Those are like using even when then, and with Karate, that's the only piece of code that you have to write. It really translates it. You create a feature branch, work on your code, push shared feature to master, and really the whole action starts about deploying this code into an environment and running the tests on them, right? So you can see that GitHub Actions triggered a deployment on AKS, and now you want to look at Kubernetes cluster, going back to VS Code and just checking the workloads there. You see a deployment coming up for the Spring Boot demo, and a pod running there for the service, right? If you see, there is a repository dispatch event, which then triggers a test execution right therein to make sure that the tests are then executed. As you see a execution trigger calling the test, and now this test are running the Kubernetes cluster again as a Kubernetes job, right? So you can literally go and check the logs, right? If when you hook this up to a reporting solution, your logs are then available in a more real-time fashion as the test execute into external reporting solutions. You don't have to really go to a console to check logs or make analytics, but that's really the next state of it, which the demo doesn't cover reporting solution, but yeah, report portal is a great tool to see that in action. You can see the tests were executed that you have, right? And then you have a lot of controls when it comes to Karate about which test to execute and whatnot, right? So go back to backstage, and you can see that your service has auto-triggered, and your test was also auto-triggered. So your tests are components of your catalog as essential as your service itself, right? So that's in a nutshell that kind of takes the continuous delivery into whole perspective. But if you look at just test automation play, you really need to focus on picking up the right tooling stack and that mindset change of having each persona contribute there with an orchestration support in terms of CICD that will make this a good success there, right? With that, I'm going to see if we have any questions coming up at this point.
Yeah, so if anyone has any questions, feel free to drop those into the questions panel right now. It looks like we do have a few questions already. So the first one is, when you work with clients, do you choose the testing tools or do they?
So I'll take this one, Larry. So we work with client in many different stages, right? We have done greenfield implementations for delivery engineering related frameworks, or we've joined midway and helped them scale the pace of development, right? So in many cases, we choose the tool considering the investments already made from a cloud affinity perspective or a technology stack perspective, the skills on the team, and any reskilling effort needed there, right?
All right, our next question is, how long does it take to make the continuous testing team part of the client's team?
I think that there are two aspects, as I mentioned earlier. Like one is developing the underlying infrastructure, right, which is basically that delivery engineering framework that provides from developer experience to a full pipeline, right? And second is really leveraging this to build the test, right? So constructing your layered pyramid of test of components and end-to-end tests. So first phase may take anywhere between 6 to 12 months, but based on complexity and features needed. The second phase really depends on the number of applications and tests, services we are creating a test for.
All right, our next question is, what are some specific demonstrable metrics you've achieved with continuous testing?
From my experience, I think we've seen a reduction in incidents due to untested dependencies, right? That has been one of the key things, right? We've seen increases in release frequency from literally bi-weekly to coming to more than once in a day kind of release frequency. Like we've seen a lot of reduction in testing effort required for sign off, right? In terms of manual testing and the quantum of the team that was required to make that sign off a reality. We've seen a huge change in how culturally the teams have moved on from there to a continuous delivery based releases to production.
All right, so we have another question about the evolution of SW architecture. Can you please summarize what changed and what lies ahead?
Okay, so from a software architecture evolution, right? Like I think the changes are kind of what we've seen in last couple of decades, from being monolith to where microservices are. I think what lies ahead is more interesting, is you look at next 5 years, and I see that cloud is going to be a very critical factor in that, right? You're going to have a lot of serverless ecosystem, where today a serverless is like, oh yeah, this is a specific use case that fits my need, and so I'm going to go to a serverless computing. But tomorrow, I think I literally see that serverless will be, the de facto way of doing things. Or infrastructure provisioning will something that will not be, it will be more commoditized in a way that you'll always have to think through a service, or it will provision its infrastructure as part of deployment and set it up itself, right? So that's a key thing. And as I said, something like developer experience is going to be key to help that. And your telemetry is definitely evolving and changing in that space.
Our next question is, how bad have some of the testing operations been that you have improved?
I think it's been a varied spectrum, right? So we've helped some of the clients redo their from team structure, diffusing the QA org itself, to shifting left in terms of their methodology, where we've been coaching developers to take on major role in test creation process. So yeah, it's been all over in last 5 years. Definitely that landscape has changed a lot in many different organizations.
All right, now it looks like that was our final question.
Great. Thank you, Lucy. Terrific questions there. Terrific job, Piyush. I'm sure any of the DZone community on here needs help with modernizing their testing environment. Come to us, come to Piyush. We can help you. Great data and experiences in there, Piyush. And thanks, Lucy, and thanks, DZone, for working on this with us.
All right, well, DZone would like to thank Piyush and Larry for a great presentation, and DZone would also like to thank Emtec for providing the audience with a wonderful webinar. And lastly, thank you to everyone who attended today. We hope you learned something new that will help you in your developer career.
You're welcome. And we can make any of these materials available after the presentation.
All right, and their contact information is up on the screen right now. Have a good day, everyone.
Have a great afternoon.